Good morning, my dear kids. In today's class, in the chapter kinematics, we are going to discuss the numericals on motion under the gravity. So if you can recollect, in the previous class, we had a discussion on the theoretical aspect, like if a body is projected vertically up, the weight of the body will provide the retardation. Similarly, when a body is falling freely, then the weight of the body is going to accelerate the body. Then afterwards, we had some demonstration, like if one heavier and the other lighter object, if both are released, both are going to have same acceleration, and they're going to have the same time of descent, and they're going to strike the ground with the same speed if they're released from rest from a certain height. So, and we went for even some graph also. That was the discussion what we had here. Okay, now what all we learned in the previous class, that has to be taken now as some sort of a reference in working numericals. Again, the numericals, the same equations of motion only, we are going to apply it. So what is the methodology here like? You have to read the question. Then after reading the question, then you have to understand the situation, what is available there. Then from that situation, you have to write down the suitable diagram, then the equations, then known and unknown, try to see, then the equations, then next the last part is the calculation and cross-checking whether we are right or wrong. This is the last part. So I think there's a very normal procedure almost in every class I used to tell. Why I'm reminding you again and again is because there's only alternative available for us, how to solve physics problem, because so many mails I got it, like, sir, how do you solve so many problems, that too with a free flow, naturally you solve it. So is there anything you do it? No, even when I read question, I do struggle, but I'll put effort. I'll try to analyze, I'll try to think what is the situation, then what is the equation. So nothing comes from granted, means we do think that something special. No, nothing, no special brain, nothing. Every person, he wants to solve problem, he has to follow this general method. So there's nothing called like a miracles here, no magic. Read question, understand the situation, link to the concept, what it is, write down the equations, bring unknowns and knowns, how they are related with the help of equation, have a suitable diagram, think on it, analyze it, solve the problem. As you keep solving problem, you will get a confidence. With that, you can proceed further. And you see that in every physics topic, it happens like at the end of the, after end of the numericals, what will get exact picture. Oh, this is what this topic is. So when you get a concept clarity at the end of the topic, not at the beginning of topic, there's nothing called like a concepts here. Unless you don't solve problem, you don't get clarity of subject. So the emphasis should be again the problem solving and thinking on that. Okay, let's, it's the best example. Yesterday we had a theory. Now let's see that how we can apply that, the ideas in different situations. Let me not waste your valuable time. Let me start the class. Okay, one more small, the statistical idea is there. First, we'll have a discussion on this, then I'll go for the numericals. So the topic is motion of a body. Motion of a body projected from a tower of height h. Previous problem, if you can recollect, we took the object which was we projected a body which was from the ground. Okay, now here. I'll take this one. Okay, there's a tower. Some yellow, I want yellow color. Lemon yellow. Like this. There's a tower. So here we are going to project a ball. With the speed. So what is the height of the tower? Let it be h. tower, all other things. Nowadays, you have a building, apartment, or some building, you'll be having canopy here. So you stand here and throw a ball. You go like this. Very simple, no? So maybe some few 100 years back, okay, it was something tower. Nowadays we have high-rise buildings. From there you throw a ball. The ball will go and will strike the ground. We are discussing motion of such ball here, nothing big. High-rise building. Oh, just building, you write it. Yes. From here you throw a ball. The ball, what is the path of the ball? The ball will go, will ascend, then will descend, will come and finally strike the ground. With what speed it will strike? At t equals 0, I threw the ball. Then after certain time t, it will come and strike the ground. We have to calculate this time of flight. What is the maximum height ascended? All the quantities. Now, what is the path of the ball? The ball is going to ascend, then it will descend, and finally it will strike the ground. With a speed v. I'll make this tower little bit. I think, okay, no, it looks very neat. So when it is projected at t equal to 0. Let me the point of projection, let me take one, highest point 2. Again, it will be at same level. Then let this be 4. Finally, it will be at 4. So then it will ascend at some height h from the tower. It will come to instantaneous rest here. Say just take some ball, go outside. Just go outside and project it. Nothing to you. Just go outside. Stand on certain high rise like a canopy or say some cliff or something like a hill, something. From there you throw a ball. So the ball will rise up, then it will fall down. This motion is what we are discussing here, nothing big here. No. So at 2, what is the state of ball? Ball will be instantaneous rest. It will be at rest for a while. Then it will fall back. Okay, first, like what is the time of ascent, time taken to move from 1 to 2? What is that h? We'll find out all these things because we know like a first thing, 0 is equal to u minus, how is g? G will be acting vertically down. So how is g? Opposite initial velocity. So therefore it is plus minus g, time taken to move from 1 to 2. How much? T12 equal to u by g. What is T12? Time taken for the ball to ascend from the top of the tower to highest point of its trajectory. Okay, there's a one thing. Then what is this h? Again, 0 square minus u square equal to minus g plus h. Now these are very important, like plus h. Why this h positive? It is measuring the direction of initial velocity. G opposite initial velocity. So therefore, finally, h equal to u square by 2g. Height ascended by the ball above the tower. Then time t3. I think we already know time of ascent should be equal to time of descent. This already previous class we had this one. Now I'm interested how much of time it will take to come and strike the ground. What time it take to come and strike the ground? Okay, let's write the equation. This is the initial point. I don't have space to scribble. Okay, this is the initial point. This is the final, no? Look at the displacement. How is the displacement? The displacement is equal to h minus h. So therefore the convention, then u t plus minus g t square. So when you're using equations of motion, so you have to substitute the quantities like a velocity, displacement, acceleration with the sign. So what is the sign convention here? Look at first the displacement. It is opposite to initial velocity. Initial velocity is u upward. And how it is opposite to initial velocity? So therefore minus h. Then what about gravity? It is measured opposite to initial velocity. Therefore it's negative sign. Not based on the motion. So it's not like so it is moving here. Now it is moving opposite to g. Afterwards it moves in the direction of g. Why don't you write plus or minus? No, not like that. The sign there, when in the equations of motion, the sign for velocity, acceleration, displacement is based on the initial velocity. If they're directed opposite to initial velocity, negative. If they're directed in the direction of initial velocity, they should be positive. Okay, there's a quadratic equation, gt square minus ut minus h equal to 0. So then t is equal to u plus or minus u square minus 4g minus h by 2g. Okay, this will be the time of flight. So what we should call time of flight or time taken by ball to move from top of tower and reach the ground. Yes, it will come and strike the ground after a certain time. This is called like a time of flight. In short, we'll call time of flight. With what speed it will strike the ground? So that also will calculate minus v whole square minus u square 2 minus g minus. Very, very, very important. I'm really interested. The signs are something very, very important. Look at that. Minus v square minus u square. So why negative sign for v? It is directed opposite to initial velocity. Not visible. I'll make it other contrast colors. Okay, no. Look at this velocity, final velocity. It is directed opposite to initial velocity. So therefore, it will be negative sign. Why g negative? Directed opposite to initial velocity. So therefore, negative sign. Why h negative? The displacement is opposite to initial velocity. Solving this is what needed. V square equal to u square plus 2gh. So the ball will come and strike the ground with a speed v. These are some quantities which we'll be using. There's a time of flight, and this is the speed with which ball strike the ground. So what will write? Speed with which ball strike the ground. What about at 3? What is the state of the ball? It will be moving with the velocity. So what is that velocity is equal to? Here it will be moving with a velocity, say v3, which is equal to u only. Able to get this? So definitely between 3 and 4, can you apply S? You'll get the same answer. So motion of the ball, we'll see here or the state of it. It will have say some velocity VA and the retardation will be downward. What about here? Here it will be accelerating. So what type of motion the ball will be describing? First retarding motion, then freely falling. It will pass through that initial level and will come and strike the ground. I think the same thing, no? You stand at the canopy, balcony, what you can call, from there you throw a ball, the ball will ascend. Again, it will pass through, you know, then go and strike the ground. That particular motion of such a ball is what we are describing here. Okay, let's go for plotting of the graphs. First, I'm interested in to plot the VT graph. Initial velocity U. Let me extend further. Yeah. And this will be initial velocity U. These are sometimes very important for us. That's why I'm trying to. So this will be minus U. This will be minus V. This is what velocity. And what about this? U by G, 2U by G, and this is P. This is about the velocity versus time graph. Then speed versus time graph. Again, I have to plot one more curve. U. Speed, this is U by G. To U by G, this is T. Now this is the speed cannot be negative. It will come and strike the ground with a speed more than the initial speed of projection. What about the distance covered? The next idea. First, it will undergo retarding motion. Then accelerated motion. Okay, this will be the time U by G, 2U by G. This is T. We have to interpret this properly. This is the position. Is it correct? Is it really right or wrong? This is something very important. I drew like this. Is it correct? So let's do one thing. It will ascend an IH. Then again to descend, no, the velocity will change, no. You see the direction of motion is not changing. So therefore, this part of curve is not correct. the entire it's a very interesting one. Just you see that one. So usually we have a practice of acceleration, deceleration, plotting this one. No. Here the curve this is the curve. So this is the 2u by g. This is time. This is u by g. This is dot that h, and this is the position. I'll write it. Hope everyone is able to understand now. See here, like at highest point, it'll come to rest. What is the slope? Slope should be 0. It is projected with a velocity. The slope should be non-zero. And if you write this θ1, θ2, magnitude of that in fact should be equal. Any reason? Because what is the speed of the object at t equal to 0 and after 2u by g should be same. Only the direction of motion is going to change. So this will be the velocity, this will be the speed, and this will be the position of a particle as a function of time. Okay, I'll give all the units. So I think these are very important for a body projected vertically from a tower of height h at t equals 0. The velocity, speed, and the position graph is given by this particular graph is what I'm displaying here. Now, what should be the slope? Slope at this point should be 0, no? Because there's at highest point. Highest point from where? From the tower. And it come to instantaneous rest here. So therefore the slope should be 0 here. Okay, there's all the basic ideas related to body projected from a tower of height h. Let's take some numericals. A parachutist drops first freely from an aeroplane for 10 seconds and then his parachute opens out. Now he descends with a net retardation of 2.5 meters per second square. If he bails out of the plane at a height and g equal to his velocity on reaching the ground will be. What is the overall problem? Suppose if this is the ground, so somewhere the person is going to okay, there's a plane. From here, he will falls freely. Okay, the person, what will happen here? He will fall freely. For what time? For 10 seconds. How some imagination like this is very important. Huh? See, writing equations, okay, but we must have a basic thing like, okay, we are discussing a problem of this situation like this. This is a ground. So in 10 seconds, he will fall freely. After that, he will open the parachute. Now he descends with net retardation. So now what is the state of him? And he is going to descend. Let me draw it. He will hold like this. Okay, now he's going to descend. So his retardation will be how much? 2.45. This let me call acceleration A1G. This retardation 2.5 meters per second square. If he bails out of the plane at a height of This height at which you will bail out. Its velocity on reaching the ground will be from here, there'll be retardation. Let me indicate that all the motion, this will be accelerated motion, free fall, or accelerated motion, I'll write it. This will be retarding motion. This will be a retarding motion. So with what speed? Okay, let me continue. I think there was some connectivity problem. So the person will come and strike along with a parachute. Will come and strike the ground with a velocity. That velocity is what we have to find out. Here you will acquire a velocity v1. Okay, let's do one thing. What is v1 is equal to? We have so many other things. We have to plot even the graphs also. v1 is equal to 0 plus a1 t1. Okay, this will be 0. Okay, this will be a1 is how much? 10. t1 is 10. 100 meter per second. After falling freely for 10 seconds, you'll acquire this much of speed. Then afterwards, is having a v1. Then it will descend certain height. No, here it will descend certain height. Can we calculate that height? H equal to a1 t1 square by 2. a1 is how much? 10 by 2. t1 is 10 square. 50 meter. Will descend 50 meter. The remaining height is going to decelerate. With a retardation 2.5. Okay, I think we can calculate. So what is the remaining H2 should be equal to? H1 plus H2 is 2495 meter. So therefore, what is H2? So this is 50 meter plus H2 equal to 2495. If you remove this 50, 45 will be there. Can we calculate now V2? V2 square, V1 square, 2 minus A2, H2. Minus 2.5, H2 is 2445. Oh, lengthy calculation. Let me simplify that here. Let me use calculator. 2 into 2.5 into 2445. 12,225. V2 is equal to, this will be 10,000. This will be 10,000. V1 is only 10, no? Okay, 100, this will be 10,000. This will minus of 12,225. This will become positive. This will be negative. Okay, somewhere we are ending up negative. Let me check the calculations once. This is 100 T1 square. Oh, yeah. I'm not that good in calculation. This will become 100. So this will end up, this will be somewhere I messed up here. So this should be 500 meter. Yeah. Now this will be 500 because root negative should not be there. So 2495 minus 500. So this will become H2 will be 2495 minus 500 will be 1995. Nobody is there to assist me. 2495 minus 500, 1995. Okay, this 1995 will be a now 10,000. Okay, this will become 1995 2 into 2.5 into 1995 9975. I think V2 square will end up with 25 and V2 will be 5 meter per second. I think he can land safely, no? He has to strike, the person should strike the ground with a very less speed. He should reach the ground and he should strike the less speed. There's all the condition. So the what retardation, what height he should bail out. I think all there's a very lot of science is involved, not like just wearing parachute and you're going to jump. So not that easy, no? So all the calculations are involved and the retardation, how much of retardation, looking at the height, where you build out, and the amount of retardation also can be controlled. This retardation also can be controlled by using these strings. So like we have to manage all this. If you bang with higher speed, it's a big problem, no? His muscles, his legs, all he may break out. So therefore, he has to strike with a less speed. He should land. Better saying, you have to strike means he should land comfortably. So 5 meters is a very small speed. You will land comfortably onto the ground. Look at the overall. Okay, now we'll go for some graphs. Huh? This will be very interesting. What about the various graphs? First, it will fall. First, the motion will check it. First, what is the motion? It will be accelerated motion. The velocity will increase. Then afterwards, the velocity start decreasing. And it not become zero, you see this. So there's a maximum speed V1 and there's a final speed V2. Okay, this is the time 10 seconds. After what time you'll strike the ground, can we calculate? Yes, we can calculate that also. V2 equal to V1 minus V1 is how much? V1 100 minus 2.5 into T2. V2 we know 500 minus 2.5 T2. So we'll get the time taken for the person with parachute open and how much of time will descend here. So this will become 5 by 2 T2 equal to 95. 19, okay, this will be 19 into 2 will be 38 seconds. For 38 seconds, what will undergo retardation. So shall we write this? This will be how much? 48. See this, the problem is very beautiful problem. Okay, there's about the VT graph. What about the position versus time graph? First it'll accelerate. Then you will undergo retardation. And it will not come to rest. You land onto the ground with certain velocity. So therefore, this will be 10, 48. So what is the total? This will be 2495. And H1 we have calculated. So this will be 500. This is a position. S equal to 0, I'll define this one. Okay, you see all the graphs. No, it will not change direction of motion. Only it's like a first acceleration, then retardation. In every problem, you must end up all the possible graphs. Let's take a balloon rises from rest on the ground with a constant acceleration 1 meter. Stone is dropped when the balloon has risen to height that it. Find the time taken by the stone to reach the ground. So this is a ground. A balloon rises from the ground with a constant acceleration. A stone is dropped from the balloon. Okay, here is the stone which is attached to it. Let's have this assumption. And the acceleration of balloon AB, I'll write it. That is 1 meter per second square. It is going to accelerate a balloon. Somewhere when balloon has risen to height, here the stone will be dropped from it. Then what is the velocity of the balloon? That will be the velocity of the stone. The balloon will be moving with a velocity, say u, at that instant. Or you can write some u1. The stone also will be moving with a ub, I'll write it. Let this velocity of balloon be vb. VB1, I'll write it. And this is stone. So this height is what available for us, 39.2 meter. G not given, so value of G will take it 9.8. What is the path of the stone? Due to inertia of motion, so that the stone is going to descend, will ascend, then it will descend, and finally it will strike the ground. The stone is going to come and strike the ground with a velocity Vs. Time taken by the stone to reach the ground. So let me call this is 1, 2, 3. This is 4. Where the balloon will keep on ascent. The balloon will continue its motion. It will continue its accelerated motion, and somewhere it is here. It will have some velocity, say VB2. Further, it will be at certain height. Let me keep this question here. No, further again, what is the state of the balloon? The balloon will further ascend, and it will be somewhere here. Please try to analyze the motion how that motion completely takes place. This will be VB3, VB3, you write it. I may ask you when the stone strikes the ground, where the balloon will be, all that. So what is our primary question? Time taken by the stone to move from position 2 to position 4. What is the acceleration of the balloon? It is 1 meter per second square. So let's calculate the velocity of balloon VB1. Yeah, I can proceed here. VB1, this should be equal to, it will accelerate from rest VB1 square minus 0 square equal to 2 times of acceleration of balloon into H. H is 39.2 meter. This, if you want, we'll write it as H. To acceleration of balloon 1, H is 39.2. Oh, so many calculations are there. 39.2 into 2, 78.4, under root of it. $78.4, 8.85. Okay, now what actually happens when the stone is released? The stone will have the velocity of the balloon due to inertia of motion. Will not be at rest, the stone. The stone. So this, what is this? Path of a stone. Due to inertia of motion, the stone will have the velocity of balloon. So what is the reason we can give? Due to inertia of motion, the stone will have the velocity of balloon at the instant of release. Not every time, at an instant of release. Okay, therefore this velocity of initial velocity of stone should be VB1, which is equal to 8.85 meter per second. And we know also H. So what is the time of flight of the stone? It will be minus H is equal to US, time taken to move from 2 to 4, plus minus G. The same minus H equal to UT plus half S equal to UT plus half it squared formula. So this will be 39.2. So this will be 8.85 T24. G will be 9.8. I think very big calculations all. So this we have to solve it. I'll try my level best. So 9.8 will be 4.9. 4.9 whole square T24 whole square minus 8.5 T24 minus 39.2 equal to 0. Quadratic equation solving this. This will be minus of quadratic equation. This quadratic equation we are solving it. So this by divided by O divided by 2 into 4.9. So 8.85 whole square. Oh. I'll try my level best to, even calculator also will take some time. We have to do 8.85 whole square. 78.325. This will be plus 4 into 4.9 into 39.2. 768. Folded by 9.8. 768.32 plus 78.3225. 846 will get it. 846.625. 6425. I'm using calculator. $30.41 I'll get it. Time cannot be negative. Time cannot be negative. So therefore, this will be plus 8.85, 39.26 divided by 9.8. Around 4 will come. This will be your answer. What is the time of flight? Time taken. Okay, this was the equation. No? Time taken to move from 2 to 4. At what height balloon will be there? Can we calculate all these things? For that, we know VB1. Further, we have to calculate this particular height ascended. Call some H3 or anything, H3. So for that, what we needed, it's going to accelerate with an acceleration 1. At what height balloon will be when stone is striking the ground? Okay, there was nothing is there. Our answer is this one. Okay, for further, we'll explore things. For that, to what height it will ascend in this interval of time. So H3 should be equal to VB1 T24 plus A T24 whole square. Then the height of the balloon will be H plus H3. When stone striking the ground, the balloon will be at this height from the ground. So what is this? Will be at this height. When stone is striking the ground. Now you have to solve this. You have to calculate this one. With what speed balloon will be moving? VB3 equal to VB1 plus A into T24. So what is again speed with which balloon will be moving when the stone is striking the ground? Speed of balloon when stone is striking the ground. Okay, like this is what the numericals you may encounter. Let me go for the next one. Read the question. A man is standing on top of building 100-meter high. He throws two balls vertically, one at t equals 0. And after a time interval, less than 2, the later ball is thrown at a velocity of half the first at t equals. Both the balls reach to their maximum heights. At this time, the vertical gap between the first and second ball is 15 meters. I think this is something very, you have to really analyze the problem. Carefully, you have to take help of the diagrams. This is the ball. We'll give different colors. So the first ball, which I'm going to throw with a speed u, ball 8 is this one. This is at t equal to 0. Okay, then the second ball, I'm going to throw it. Ball 1 will take it. This is the ball 1. The second ball, I'm going to throw it with a velocity half of the first ball. Okay, there's some instant of time. Let it be t1. And at that instant where the first ball will be somewhere here. I think this is the very important part of the problem. The ball 1 where it might have ascended some height. No. Finally, after time interval, the later ball is thrown at velocity of both the balls reach to the maximum heights. At t equal 2 seconds, both the balls will reach their maximum height. Okay, this ball 1 will be here. It will be at its maximum height. Ball 2 will be at its maximum height. You can see this. So what shall I call this? This is the maximum height of the second ball. This is the maximum height of the first ball. This difference is what? 15 meters. See, if you draw a diagram, it's very easy what's going on. So all the information is what I have put everything in the diagram here. Now, let's come for this one. What is H1M is equal to? U square by 2G. What is H2M? U by 2 whole square by 2G. Because with what speed the ball 2 is projected with the speed half of the first one, U by 2. So therefore, this should become equal to U square by 8G. The difference of that we know, H1M minus H2M. U square by 2G, U square by 8G. So this is equal to how much? 15. So 3U square by 8G. Do we know u? We don't know that. We can find out here now. So this will be 15 is equal to 3u square 8 into 10. Solving this, u square 400 meter per second, u equal to 20 meter per second. The speed of the first ball, we got the answer. The 1, 2, I'll write it. Answer for the first one. Next, the time interval between the throw of the balls. Okay, this T1 is asking, or delta T. What will be that? What is delta T? Time interval between throwing of the balls. Time interval between throwing of balls here. How to calculate that? What is the time of ascent of the first ball? U by G. That of the second ball. Only time of ascents. And we know velocities. So velocity is how much? 20 by 10. This will be 20 by 210. So this will be 2 seconds. This will be 1 second. So what is delta T? Delta T will be after certain time, it was the other ball is thrown. No? So the delta T should be equal to T1 minus T2. So this is the time interval. Already I written. So this is our answer for second one. Say I'll throw the first ball. After certain time, I'll throw the other ball. So what is the first ball? How much of time it will take to reach here? 2 seconds. What about the second ball? From here, the time measurement will be 1 second. So there's the interval of time will come. So the first ball will take 2 seconds to ascend. Second ball will take 1 second to ascend. The difference of that time interval is what? The time interval between the throwing. This is, I think, very important idea here. How you are writing this is very, very essential. The difference in the time of ascent will be the time interval between the throw. So what is this time of ascent of the first ball? This will be time of ascent of second ball. Okay, this will be our answer. Finally, we got that. We have to just, I think the diagrams are very essential. Once again, I'm insisting, please do all of you. You have to understand the question, you have to read question, then understand the diagram, then understand the situation, then get the diagrams, then looking at the diagrams, bring the equations, then check for knowns and unknowns, then work out. Let me go for the next one. There's a very general problem you might have seen. In fact, you can try at home also, all these things. Water drops fall at regular intervals from a tap of 5 meters above the ground. The third drop is leaving the tap at the instant the first drop touches the ground. How far above the ground is the second drop at this instant? It's a very simple to diagram here. So you can go and practically open the tap, produce a small opening in it. Don't go for big opening, produce a very small opening. There's a tap. Okay, that tap, I'll bring it. Okay, this will be the tap. The first drop at t equal to 0. This tap is at what height? It is at height of 5 meters. When the third drop, okay, no, first drop will come. This will be a dropper. This will be the first drop. It's going to fall freely, no? Yes. Then when the first drop is here, the second drop will emerge out from the tap. What is the state of this? This will be moving with certain velocity. Regular intervals from a tap 5 meter above. The third drop is leaving the tap at the instant when first drop touches the ground. I will do one thing. Yeah. This will be first. Okay, when the first drop is striking the ground, the second drop will take the earlier position of the first drop, and the third drop is leaving the tap. I think there's the overall sequence. Now, what is the how much of height the first drop will descend? 5 meters. H is equal to G T square by 2. Okay, this is 5, 10, 2 T squared. T equal to 1 second. So after 1 second, T equal to 0 has started. And the 1 second, after 1 second, the first drop will go and strike the ground. Okay, able to get this? Now for above the ground is second drop at that instant. I think regular intervals, no, that regular interval delta t has to be calculated. So how many delta t's have passed? 0.5 seconds. So this is 1 t. Okay, here. So what is the time? 1 delta t. 2 delta t occurred because regular intervals has to take place. So therefore, that 2 delta t is what? 1 second. So delta t equal to half second or 0.5 second. Then how much of height the second drop will descend? H is equal to some HL, right? Equal to G into delta t whole square by 2. 10 by 2, delta t is 0.5 whole square. This will be 5, 0.25. 1.25 meter. So how much of height? Second drop in interval of time delta t will descend this much of height. So what height it will be there, the remaining? 3.75 meter from the ground. Now with what speed it will be moving? Speed of this, can we calculate? Five meter per second. Call this as say V1. VA will call it. Now, what about the V? VB will call it. We'll give some name. VB, VB. This is VA. What about VA? VA will be G into T. We can also predict all the speed of the drop. So like this, you can do for, if you increase the height 10 meter, 20 meter, you can do for 5-6 drops. At various instance, the drops will be at different position. Let me take the other question. A stone is dropped from the top of a tower when it is fallen 5 meters from the top. On this, when it has fallen 5 meters from the top, and the stone is dropped from a point 25 meters below the top. If both the stones reach the ground at same moment, then height of the tower from the ground. Okay, this. Just have some rough analysis, that will be more than sufficient. The first stone is what I'm going to drop it. The first stone, I'm going to drop it at t equal to 0. When it's fallen by 5 meters, when the first stone has fallen by 5 meters, another stone is dropped at point 25 meters below the top. Okay, this is called as a top. Another stone, I'm going to drop it 25 meters below. Okay, so this is released from rest here. This is also released from rest. Next time, both the stones reach the ground at the same moment. Both will reach the ground at the same moment. Look at now. Yeah, no, this will be 1. This will be 2. With what speed they'll strike? They will strike with a different speed. Let's not bother the speeds. They'll come and strike with a different speed, and both will strike simultaneously here. What is this? This will have some velocity here, no? Let me write you one. This is released from rest. Can we calculate this time? Then the height of the tower from the ground. Okay, this delta T, I'll ask it. That capital H is has to be determined. So how much of height the second stone will descend? H minus 25, and it will take some time. What is delta T? Time interval between throws. That has to be determined. Okay, for that I can calculate the delta t, because how much of height the first stone will descend. It will descend 5 meters. So phi is equal to g by 2 delta t. This is 1 second. After 1 second, the first stone is going to, like, it will take time, 5 meters, this one. So I think I'm indicating everything in diagram, because it is released from rest. When it descends by 5 meters, the second stone is released here. So what is the time interval? That is what delta t we have calculated. Okay, now can we calculate that U1? U1 should be equal to G delta T. Okay, I think these are enough for us. Now, okay, what is the height? The second stone will descend, or the second stone will descend H minus 25. This height. How much of height it will fall freely? What height it will descend? H minus 25. See this. So now we know T? We don't know that T. What height the first stone will descend? H minus 5. So this H minus 5 is equal to, this should be equal to G T square by 2. Is it okay justified? No, actually you have to write U1 T plus G T square by 2. U1 we know as 10 T plus, this will be 10 by 2 T square. This will be 10 T plus 5 T square. This after solving 5 T square. We don't know that T also. Now we will do one thing. H minus 5T square value is how much? H minus 25. Can we calculate anything? H minus 25. Okay, I think I had, let me look at the calculation first. We know U1, no? Other side, we should take help of U1 also. U1 I substitute 10T H minus 25 equal to half GT square. GT 5T square I'll replace this 5T square here. Let's see further. Let me give number 1. It's about mathematics here. We know we have wrote equations. We have to search for from 2 and 1. So H minus 5 equal to 10T. 5T square will be H minus 25. This H will get eliminated. 25 minus 5 equal to 10T, or T equal to 2 seconds. Once you know T, then you can bring the H value. This is equation 3. Put 3 in 2. H minus 25 equal to 5T square. H minus 25. 5 into 2 square. H equal to 45 meter. Okay, this will be the our answer. Okay, these are the some. We have to look at some maths also. We have to look at the equations and see that what calculations you can do so that you'll get the required answer. Let me go for one more. Yeah. A balloon starts rising at an acceleration. After some time, a stone is dropped from it. If the stone reaches the ground in the same time, and if the balloon reached at this point from where stone is dropped, find the acceleration of the balloon. I think we have to read the question. Yeah. A balloon starts rising at an acceleration. Okay, this is the balloon. And a stone is attached to it. For our convenient. Rising at an acceleration. Okay, to start accelerating from rest. After some time, stone is dropped from it. So when the same balloon arrives here, somewhere when it is at a height from the ground, a stone which is there, let's assume that is dropped from it. Dropped from it means, will it be released from rest? No, no. It will just, as it is released there, it will have the velocity of balloon. With what velocity the balloon was moving, with the same velocity, the stone will move. The stone reaches the ground in the same interval of time in which balloon reached at this particular thing. So let's do one thing. 1, 2. What time the balloon takes? Okay, this is 2, 3, 4. T12 should be equal to T234. It has risen certain height h. So what is the primary information given for us? What is the information given? The information given is T12 is equal to T234. Let me call this as T. Find the acceleration of the balloon. Okay, the balloon is going to accelerate. This acceleration has to be determined. So here you bring all the things. So first we'll calculate the UB. UB should be equal to 80. Acceleration of balloon is A. Then what about H equal to AT square by 2? H equal to AT square by 2 it will be. Then minus H equal to US T minus GT square by 2. Now look at now, UB should be equal to US. Any reason? Due to inertia of motion. Due to inertia of motion, the stone will have the same velocity as that of balloon at an instant of release. At an instant of its release. Okay, we have, okay, what is H is equal to AT square? Acceleration of balloon that is asked here. Okay, and US equal to UB. So let me substitute all the things. I'll give numbers. There's a 1. 2, 3. Substituting 1, 2 in 3. So H is equal to minus AT square by 2. US is equal to AT. This is GT square by 2. Minus AT square gt square by 2. So gt square by 2, moving this to LHS, gt square by 2 is equal to at square plus at square by 2. So acceleration of the balloon. This is your answer. So the initial symbols are very important. The equations 1, 2, 3. And next, this idea. I'll write it. Very important. Very important idea. A ball is projected up such that it passes through a fixed point after a time t1 and t2 respectively. Find the height at which the point is located with respect to point of projection and the speed of projection of the ball. There's a ball. I'm going to project it. There is some point. So where is that point? That point is what? Somewhere I'll choose this. It passes through a fixed point. A, let me call B, C, D. It will cross it with a velocity V. It's a ball. Then the ball will come to instantaneous rest here. Again, it will pass through the same point with the same velocity. Then what is the information given for us? TAB is T1, TA TBCD is T2. It passes through a fixed point after a time T1 and T2 respectively. I'm assuming conditions. So T1 and T2, this I have to measure ABCD. Yeah, sorry, yeah. TABCD. Time taken, or this will become T2, this will become T1. Okay, let's do one thing. Okay, let this be height H unknown and U. These two things are that is being asked. So let me write all the possible equations. H is equal to UT1 minus GT1 square. Then again, same H equal to UT2 minus GT square. This is what I'm for the ball is projected. No, what is the T1 time taken by it to ascend to height H? What is again H I'm writing because again the ball will be at same height after what time? After the interval of time T2. Equating these two. UT1 GT1 square UT2. So this will become U T1 minus T1 plus T2, T1 minus T2. So what is the value of? This is the initial velocity. What is U? U is initial speed of projection of ball. Find the height is asking h. Okay, this equation 3 I'll put in either 1 or 2. Put 3 in 1, h equal to u. Value of u is g t1 t2 by 2. G t1 square by 2, g t1 t2 by 2. Height of the point. Height of the point from the ground. And these are the answers. Okay, just you have to understand this diagram properly here. Now one more thing. Why negative? Because the g will be here directed opposite to initial velocity. Why h is positive? Because the displacement you are measuring in the direction of motion. Hope are you able to look at this sign? Why negative sign? The g will be directed, acceleration due to gravity is directed opposite to initial velocity. Why positive sign for this? Because the displacement is measuring the direction of motion. Last we'll have one more numerical. Yeah. A body is thrown vertically up from the top of a tower. It reaches the ground in time t1. No, there's a ball. A body is thrown vertically up from the top of it, reaches the ground in time t1. If it is thrown vertically down with the same speed, it will reach the ground in time t2. It is allowed to fall freely. Then what time it will take? Okay, let h be the height of the tower. Here this time is t1, this is t2. We have to calculate this t. Here release from rest. Projected up. Projected vertically up. It is projected so in all the cases, it is going to descend same height. So it will be released. So it is going to fall freely. You can ask question like, what about the speed with which it will strike? Yes, it will be different. V1. I have to give same color. Here it will come and strike. With what speed it will be striking? Yes, it will definitely, in these two cases, it will be same speed. Here it will be V3. V1 equal to V2 and not equal to V3. That in the end of the problem, we'll see it. Okay, let me write all the equation. Minus h, looking at this. What is the displacement? This is t equal to 0. I'll measure the time. After some time t, it will be here. Then what is the displacement? You see that opposite to initial velocity. So minus h equal to u t1. Why negative sign? The g will be directed opposite to initial velocity. There's a one equation. Then h equal to u t2. Look at here now. Why g positive here? The g will be in the direction of initial velocity. Are you able to understand now these two situations? You see it here. I took h negative. The reason, because that displacement is measured opposite to initial velocity. Here the same h. It is in the direction of initial velocity. I'll indicate this in the direction of initial velocity. So therefore, this is positive. Why g negative? Please notice this. Okay, the last case, h equal to g t square by 2. We have to just solve. We have to search a condition. We'll try to simplify this. So this will be this equation. I can rewrite it as T1, T2, all they are needed. Let me bring expression 4. I'll add up these two. I'll add up these two equations. Oh, I don't know why I moved it. Equation 1, equation 2, equation 3. 1 plus 2. So this will become 0 u t1 plus t2. So T1 plus T2 will go outside, will get eliminated. So U is equal to U plus G by 2. T2 minus T1 equals 0, or U equal to G2 equal to T1 minus T2. Equation 4. This 4 I'll substitute in either 2 or 1. Put 4 in 2. H is equal to U. This will be G by 2 T1 minus T2. Okay, GT1 minus T2. This is T2. GT square by 2. Okay, this will become GT1 T2 by 2. GT2 square by 2. These two will cancel out. H equal to GT1 T2. Okay, this let me call equation 5. Then equating 5 and 3. So T equal to T1 T2. This will be your answer. These are the some we have to interpret. Say like I feel like these are the most essential. First, writing these three equations. There's a fundamental idea. So writing these equations. Important idea. This diagrams, draw this diagram after reading this question. After reading this question, a student must able to draw diagram. Then looking at diagram, writing equations, generating this. Afterwards is a calculation part. After this, a calculation part. But if you're not good here, all these things will not help. Please do understand. First, actually, the priority is like the diagram. I feel like the priority should be the diagram. This is very important. Drawing diagram is something is very, very essential. So what is the thing like? Anyway, like I just, I'll summarize here. So first, read the question. Read the question. Understand the situation. Draw the rough diagram. Looking at diagram, write equations. Then search for how known and unknown are related. Next, calculations. There's a fundamental one. You go for any problem. There's only methodology which are available. Look at the diagram and write equations. Look at the diagram and write. I think this 3 and 4, 2, 3, 4 are something. Look at the diagram and write equations or search for idea. Or explore the idea. Okay, I'll end up the class. I had to attend the college also. Okay, kids, like we had the discussion about the motion under gravity numericals. I think around some 7 numericals or 6 numericals we have discussed here. So in almost all the numericals, the necessity of what, like read the question, then understand the situation, then corresponding to that, draw the diagram, then what equations you can write it, looking at the situation or what is the idea involved. Then comes calculation. There's only method available. If you have anything easier than that, please do share with me. I'll be very happy. Some may feel very tough. If you have really easy method than this, you can share with me. I'll accept it 100%. But this is what I feel like the conventional method of solving the physics problems. What I'm giving general approach, the whole physics will revolve around this methodology. So I don't want you to become a parasite. Means not like something depending, like you try to depend on my app. It is. So my methodology is like to make you to think, to make you to solve the problem. The more you become independent, I'll be more happy. It's not that you should regularly use my app. So my methodology is like to make you to think on your problems and to make you to solve the numericals on your own. That's why I'm bringing all these many numericals. At least after looking at all these numericals, you must go forward and start solving the numericals. This is the primary purpose of I'm sharing the knowledge. Okay, we'll meet in the next class with still more some better numericals where you have to put a lot of effort. Okay, thank you all of you. Take care, bye, see you.